Example 6. Fluid mechanics. Chapter 7. A high-speed car with mass of m equals to 2000 kilograms and drag force coefficient equals to 3/10, and the effective area is 1 meter square. A 2-meter parachute to slow down as shown in this picture. Parachute 2m diameter. To slow down from an initial value 100 meters/second to hypercar, assuming constant drag force coefficients. Brakes free and no rolling resistance. Calculate the distance and velocity of the car after 1, 10, and second and 1000. So calculate the distance and velocity at 1, 10, 100, 1000. For air, assume that density is equals to 1.2 kilograms on m cube, and neglect interference between the weight of the car and the parachute. Also, Newton's law, and if we want to have an expression to the car velocity and the forces, we should write the Newton law on Newton's second law, which says that sigma f, for example, in x direction equals to max. In this case, we have also f x m, the derivation of velocity in time. Now we should calculate the forces. We have two forces, the force due to the drag and the force due to the parachute. So we have sigma f in the, if we choose the direction of x and y as this coordinate, we have minus fc minus fp. We have relation for various drag forces. The first drag force due to the car is, for example, minus rho u square multiplied to the area multiplied to the c d plus minus c d parachute car rho u square a. So we can make a simplification. Rho u square is same minus cd car a car plus drag force parachute and the a of parachute. So we have this relation for this problem, which can be, let me write, u2 or v2 minus v2 multiplied to the sigma cdi rho I ai. This, if we name this expression as k, so sigma fx equals to minus k v2. With the make an equality between this relation and this relation, we can obtain minus k v2 m dv on dt. So we have this relation for dv on dt ds squared. Now we can make an integration with the appropriate dv on v2 minus k on m dt. So with the integration, for example, from v0 to desired v, from to 0 to time t dt. Now we can calculate minus k on m t from 0 to t, to replacing the with eliminating this minus sign, we have k on m t. In this case, k equals to cd car a car plus cd parachute a multiplied to the density 2n. And now we can also have a relation for v one on v on v0 m This is a relation for the velocity. We can integrate this, find the distance also with this relation. We have ds on dt equals to v. We have v0 m plus k v0 t. So ds equals to v0 m dt So the integration is S from 0 to T. It is K. Let me make a correction. V0 dt on 1 plus K on N V0T. Now we can have the relation S Ln M on cos V0 M on cos V0 Ln with the calculation we can obtain the time. Let me write again for V and S. So V was equal to V0 on alpha Ln 1 plus alpha T, alpha equals to K V0 on M. The calculation we can obtain the results at, for example, T 1, 10, 100 and 1000. We should first calculate K alpha and make a calculation to this table for example B and S.